Hello everyone, reporting today for Fun Robotics Network. I'm Abhas, and with me here is Team 2871 Eureka from India. They have been absolutely fantastic this season. Coming into the Houston World Championship, they were the Edison Division winner. Perhaps more importantly, you are Into the Deep World Championship finalists. Absolutely fantastic matches, match after match, just super awesome specimen cycles. They have really great hang mechanisms, very fast specimen alignment mechanisms. I can't wait to jump into it on Behind the Bot. Okay guys, so first question is with the architecture. We've seen a lot of different designs. We've seen, the two slide architecture is pretty common this year. Why did you guys go for it specifically?
Right, so what I'd say is first we just looked at a lot of designs online. A lot of people had posted a lot of designs on Discord. There were a lot of challenges that were done. And so we basically learned from there. We looked at the most common intakes, how they work, all of the transfers, etc. And just we built up on that, and we just kept on improving on that.
Okay, got it. And now jumping into the intake itself, it's very light and small. What were some of the packaging concerns, and why did you make it so small out here?
So one thing we made it quite small is we knew that a lot of robots are going to be intaking from the submersible. So to utilize minimum space in the submersible so that we can pick up, while other robots are trying to pick up, we can first pick up and run. We tried to make the intake as small as possible. So the width of our robot is just 13 inches, which is quite small compared to the other robots. We've mounted our intake on just one single Gobelda bar, which keeps it around 4 inches wide.
Yeah, and can we see an intake cycle real quick if you don't mind? And as far as the claw itself goes, I see here you guys have your claw, it's pivoting, but also the gripper geometry is very unique. Now that you have this sample in here, can you walk me through how you determine this gripper geometry?
Okay. So when we started off, we actually tried off an active intake, but it didn't work out well because we didn't have enough motors. So we added a gripper. First, we had a thick gripper, it had a thick base. It was not pointy like it is now. We added a gripper which was thicker at the bottom. But what we faced a problem was that when there were samples in clusters together, the gripper was not able to pick it up. So then we added a pointier gripper which would shake the samples down and it would allow us to pick a sample which is in a cluster.
Cool, yeah. Now jumping into these slides a little bit here, I see a lot of BWT slides all over the robot.
Yes.
Why go with those?
So the number one reason why we took BWT sliders is because they have inbuilt bearings on them from which we can do the stringing. So as you can see here, these are the inbuilt bearings that the BWT sliders have. So we don't need to add any extra 3D printed casings or anything to do this stringing.
Yeah.
Because adding those would make the robot bulky, which would again take up a lot of space while intaking from the submersible.
And I know a lot of teams have started stringing only on one side instead of both, but you guys have done both sides stringing.
Yeah.
Why did you go with that?
Okay, so we added both sides because sometimes we did include only one side of stringing, but sometimes whenever we used to open the intake, if a slider got stuck inside, it would just stay there. It would not come ahead with us. Mm-hmm. So then that would cause the sliders to break as well as the intake to break. So then to ensure that both the sliders are opening at the same point, we added stringing on both sides.
Cool, and is it 2 motors for the intake extension or
no.
just 1 motor?
So we have 1 motor for the intake extension, and that's it.
Okay, awesome. Jumping into the deposit mechanism, you guys have this really awesome polycarbonate guide over here. Walk me through how it works, what it does. Talk about it.
So that is our specimen aligner. We've just recently introduced it in our bot before we came to the World Championships. So we saw a lot of robots using it, and we also thought also during auto, sometimes the body used to come a little to the left, a little to the right. So this used to really help our human player in aligning the specimens and basically help it be consistent while picking it up from the wall, right?
Yeah. And
so we don't really use this in when we're doing samples. So this is usually just helpful when we do it in specimen mode.
Yeah, and as far as specimen cycling goes, what automations do you have throughout teleop to make sure your drivers can go just as fast as possible?
So during teleop, we do not have any automations. We do not use a limelight or anything during teleop. The only thing that we've added is that we take the intake all the way in and we put it inside the robot, so that it does not hit onto the submersible.
Okay.
So we can just cycle quickly.
Yeah, and as far as picking up the specimen, any automations there, or it's completely
driver based.
Okay, got it, yeah. Going on to the hang, let's start with the level 2 and then we'll talk about the level 3. Walk me through the level 2.
Yeah, sure. I can show you all the level 2. So as you all can see, level 2 hanger is mounted upon again BWT sliders, and it has carbon fiber plates. So we have two passive hooks which are powered by rubber, not powered, but they're attached to rubber bands. So whenever our motors go up, the hooks open, and then we latch onto the lower rung. So after we latch onto the lower rung, the BWT sliders go down, and once they've gone down, we start our ascent with the higher sliders, which we have passive hooks here as well, mounted on our outtake mechanism. The delivery mechanism.
Yeah.
And
so talking about the level 2 specifically, is it motor powered, servo powered? How does it work?
So we have one motor which has a 45:1 gear ratio, which is right here, and it powers the entire lower hanging.
Cool. And now going into the upper hang, I see you guys have your slides angled. Was that entirely because of the hang, or what was the decision there?
Yeah. So we angle the slides just for the hanging, as many teams this year use their Specimen arm to pull this rungs closer to them and then hang, but that used to take up a lot of time. So we incline the sliders to 75 degrees with the ground, so that we can just directly go latch on and hang.
Yeah, and I know you guys are another team with a PTO. It seems just like all the top teams this season have PTOs or gear shifters. Walk me through what your mechanism does.
Yeah, so our gear shifter is quite unique. So what we have here is we have a dog shifter mechanism. So we have one big gear and a smaller gear. The big gear, of course, gives us higher torque, and the smaller gear gives us higher speeds. So during autonomous, the latch over here, which is powered by one servo, is shifted all the way out, which engages the smaller gear. It works like the clutch of a car. So there's a ball bearing placed. There's a ball inside, which will go into the the smaller gear while hanging, during telly-up. And when we need higher torque while hanging, we just push in the shifter, which moves the ball bearing inside, and then the torque of the motors increase.
Awesome. Yeah. And is this gear shifter something you guys developed? Was it you had a mechanism you were able to purchase? Walk me through that.
Yeah. So we purchased all the parts separately, and then we manufactured it ourselves.
Very cool. Yeah. And talking a little bit about driver practice, when you're doing your specimen practicing, what do you think is something you do different that makes you so consistent on the competition field?
So one thing we did a lot is just practicing parts. So we would just go cycling specimens, not picking up, not intaking any, just doing specimen cycles to increase efficiency at that time. And also we focused on doing the same amount of cycles in lesser time. So we used to do 1 minute, 30-second practices for 10 specimens, 12 specimens, so that when we have that extra 30 seconds, we will be able to do more.
Okay, yeah. Team Eureka, thank you guys so much. Just a very optimized but simple robot that you just drive super, super well, and that shows. I mean, World Championship finalists, that's very, very impressive. Reporting for Fun Robotics Network, I'm Abhas, and this is Team 20871, Team Eureka.